Hello, Algebra class. So for today's video, what we're going to be doing is we are going to be going over the notes from Unit 7.1, adding and subtracting polynomials. The first thing we need to do, though, is understand some vocabulary. So before we get to polynomials, let's talk about what a monomial is. Mono, of course, means one. So a monomial is a number, a variable, or the product of numbers and variables. Something like, as we see an example down here, 3x or 1/2 ab squared. There's a number, there's a variable, or there's a product of variables. That is a monomial. Another name for a monomial is a term. So if you ever talk about combining like terms, or you hear me talk about a term and monomial are absolutely completely synonymous. We are going to be talking a lot about the degree of a monomial, and there's actually a meaning to what the degree is. We'll worry about that later, though. The degree of a monomial is the sum of the exponents in the variable. Ooh, I didn't need to zoom out and zoom in. That's getting a little strange. Sorry about that. So the degree of a monomial is the sum of the exponents in the variable. So for 10, yes, that's a monomial. It's just a number, but there are no variables. So what's the exponent on a variable if it's not there? It's 0. Like x to the 0. What is x to the 0? X to the 0 is 1. So 10 times 1 is just 10. And that's why you can say that monomial like 10 has a degree of 0. 3x, what's the exponent on the x? Well, the exponent on the x is 1. So the degree of this monomial is 1. 1/2 ab squared. All right. Now I have two variables. It's the sum of the exponents of the variables. Okay, so the exponent on A is 1. The exponent on B is 2. So 1 plus 2 equals 3. The degree of this monomial is 3. And here I have negative 1.8 m to the fifth. There's only one variable, so I'm just going to look at the exponent here, and that's 5. So the degree of that monomial is 5. Before we go on to anything else, let's just see some non-examples of monomials. 5 plus x. That's not a monomial because there are two terms. We'll actually end up calling this a binomial because there are two terms. Bi, of course, meaning 2. 2 over n, that's not a monomial because the monomial cannot have a variable in a denominator. 4 to the a. No, I can't have a variable as an exponent, so that's why this is not a monomial. X to the negative first. That's not a monomial because the variables must have exponents that are non-negative. So whole numbers are okay, 0, 1, 2, 3, 4, all the way up. That's fine, but no negative exponents. Okay, so a monomial, a number and a variable, or the product of numbers and variables, and the degree of a monomial is the sum of the exponents of the variables. Okay, so find the degree of each of the monomials below. 5x squared. X is my variable raised to the second power. That's degree 2. Negative 1/2 x y to the third. X and y are variables. The exponent on x is 1. The exponent on y is 3. 1 plus 3 is 4. 8x cubed y cubed. X to the third, y to the third. 3 plus 3 is 6. Negative 3. There is no variable, so that has a degree of 0. Okay, some more vocabulary. A polynomial, all right, mono means one, poly means many. A polynomial is a monomial or the sum or difference of monomials. So back up here when I said 5 plus x, that's not a monomial. Those are two terms. This would be considered a polynomial. A binomial, two-term polynomial, 5 plus x. If bi means 2, tri means 3, a trinomial is a three-term polynomial. All right, the degree of a polynomial. Well, we went over how to find the degree of a monomial. For a polynomial, what we'll do is we'll take each of the terms and we'll find the degrees of each of those monomials. And whatever number is the largest, we're going to call that the degree of the polynomial. So up here, I have 5 plus x. The degree of 5 is 0. The degree of x is 1. 5 has a degree of 0. x has a degree of 1. This has the bigger degree of 1, so we're going to say that the degree of this binomial is 1. We'll see some more examples later. And standard form means we're going to take a polynomial and we are going to rearrange the terms, rearrange the monomials so that they are in descending form, in descending order by degree. So we want the terms with the highest degree in the beginning and the lowest degree at the end. Okay, so let's take a look at some examples. All right, find the sum or difference. So here we are going to combine like terms and then find the degree of the polynomial afterwards. So I have a 2x cubed, and there's nothing to, oh, look over here. There's a plus x cubed. 2x cubed plus x cubed is 3x cubed. Minus 5x squared plus 2x squared is minus 3x squared. Plus x, now there's nothing to combine with the x, so we keep the plus x. And the minus 1, nothing to combine with that. So notice that this polynomial is in standard form. 3x cubed minus 3x squared plus x minus 1. This term, what's the degree? Well, there's an exponent with the x, and that's 3. That's a degree 3. X to the second, that's degree 2. X, that's degree 1. Negative 1, that's degree 0. So I have 3, 2, 1, 0. What's the highest degree? It's the first one, degree 3. That's why we say this is a degree 3 polynomial. Let's try this one over here. 3x squared plus x minus 6 plus x squared plus 4x plus 10. All right, 3x squared, I can combine that with x squared. 3x squared plus x squared is 4x squared. Plus x plus 4x is plus 5x. Minus 6 plus 10 is plus 4. So 4x squared plus 5x plus 4. That's my final answer. Let's find the degree of each term. X to the second, that's degree 2. X, that's degree 1. 4, that's degree 0. So you can see standard form, degree 2, degree 1, degree 0. So what's the degree of the polynomial? Well, my highest degree term is the first one of degree 2. So we call it degree 2. There are 1, 2, 3 terms, which is why it is a trinomial. Okay, let's do the next one. 4n to the second plus 5 minus negative 2n squared plus 2n minus 4. So you see the parentheses here? We're subtracting. We have to distribute that minus to everything there. Okay, 4n squared plus 5 plus 2n squared minus 2n minus a minus is a plus 4. Now let's start combining. 4n squared plus 2n squared is 6n squared. Minus 2n, nothing to combine with that. There's minus 2n. Plus 5 plus 4 is plus 9. So notice, standard form. Second degree, first degree, 0 degree. Of my 3 terms, there's my highest degree. It's degree 2. So we call this a degree 2 trinomial. Over here, 4x squared minus 3x plus 5 minus 3x squared minus x minus 8. Again, we'll distribute the negative. 4x squared minus 3x plus 5 minus 3x squared minus a minus is a plus x minus a minus is a plus 8. Now let's combine like terms. 4x squared minus 3x squared is an x squared. Minus 3x plus x minus 2x. Plus 5 plus 8 is plus 13. So again, notice standard form, degree 2, degree 1, degree 0. It is a degree 2 trinomial because there are 1, 2, 3 terms. All right. Now we have a real life problem. A penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. The polynomials represent the heights in feet of the objects after t seconds. So if I asked you after 1 second, where is each object? I would replace t with 1, and that would be the height. I'd replace t with 1. That would be the height. The reason this has a minus 40 is because the penny is thrown down with some force, and there's no minus anything t. There's no linear term. There's no middle degree 1 term, is because it's dropped. We're going to explore that a little bit more when we get into projectile motion, which is coming up later. Okay. So write a polynomial that represents the distance between the penny and the paintbrush after t seconds. All right. Anytime we want to find distance between two things, that always means subtraction. So we are going to subtract the height of the penny and the height of the paintbrush. We're going to subtract those two polynomials. So we have negative 16t squared minus 40t plus 200 minus negative 16t squared plus 100. All right, let's distribute the minus. Minus a minus becomes a plus 16t squared. Minus a 100 becomes minus 100. Now let's combine like terms. Negative 16t squared and positive 16t squared, they cancel. Negative 40t, nothing to combine with that, plus 200 minus 100, that is the plus 100 that you see here. Okay, I know they weren't asking this, but we would classify this, because it has two terms, as a binomial. We can also say this is a degree 1 binomial, because this is the only term that has a variable and the exponent is 1. So this is a degree 1 binomial. Interpret the coefficients of the polynomial in part A. All right. So the objects start 100 feet apart, and the gap between them closes by 40 feet per second of free fall. That question is a little beyond what we're ready to do. At the end of this video, and any rewatching or practicing that you do, I will be very happy if you could just take the polynomials, add them and subtract them, put them in standard form, and understand how to find the degree of each term and the degree of a polynomial. All right. So thank you for watching this. Please feel free to watch it again if you need to. Write down any questions that you might have, and either email them to me, or when we go live, make sure you ask them then. All right, guys. We'll see you the next time.